Good morning. Good morning, everybody. Good morning, Namaskar. This is Engineer Suraj Singh. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 24, 2022. Monday, this is 3:56 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक जनवरी 24, 2022 सोमवार सुबह के 3:56। क्वालिटी इशू। Title of talk, as usual, is nothing special but quality. Quality works. Concrete specifications, civil field engineering, life engineers, contracts, quality structures, designs, construction, methods, contracts, etc., same as usual. Nothing very specific addition on this, but issues are different. This is my name and my address. Email ID, address is also there. It is there 430-21B, Faridabad. Phone number is also there, but no use of phone number. I am not going to attend any call because calls don't serve any purpose. If you wish, if you respect profession, you can send email to me. ID is suraj_engineer@yahoo.co.uk. My enrollment is FIE with the Institution of Engineers India, Royal Chartered Body, Chartered Engineer India. It is according to Royal Charter, title is Chartered Engineer India, and according to international agreement, title is International Professional Engineers India. These both titles currently I am holding, and I have qualified basically full degree in civil engineering. I am not master's, I am not doctor, I am ordinary engineer, to be very frank. Academically, I am not very advanced. In professional work, I did something, I can say not wonderful, but usually it is commendable. There is another certificate, that is same certificate for your display, for you let to know. And this is how it is issued, and title is Suraj Singh is certified as International Professional Engineer India in field of civil engineering, and is hereby authorized to use style and title INT PE India, and this certificate is valid up to this date, and for me it is September 30th, 2025, and it was issued on this date, 30th September 2020. I got first such certification of INT PE India in 2012 and 2015, and then 2020. It is that, just for your information. And this is Chartered Engineer Certificate, as I said. This is per membership by virtue of qualification, professional training, and corporate membership of this institution, which is Institution of Engineers India. This person is hereby authorized, style and title Chartered Engineer India, and this is fellow, that is membership. Fellow and means it is the highest level of highest grade of membership. There are 3 grades. Starts with AM, associate member, then member, and then fellow. And of course, it is statutory membership. Institution of Engineers India is body corporate in eyes of law, chartered body. And what we have to do is we have to go to quality file. I close the FI file, and I close C file. And we have to confer on something that is quality related, because it's very important issue. It cannot be taken just for granted. It has to be taken very seriously, because quality is always a question mark. But nowadays, currently, it's immense level question mark, or you can say number 1 question, because I, as an engineer, feel quality has been compromised and being compromised, and that is not acceptable to me, to be very frank. It's not acceptable to me, because quality is quality, and cannot be taken for granted. Quality cannot be taken for granted. That is what to be understood and to be taken care of. There were some files that I thought I could download. I downloaded also those files. One is nuclear power plant, and that is of course 861 kb. So, I'm just trying to get you one very important paper, curing diaphragm wall, different types of derivative concrete, art with precautionary tips for concrete. This was is actually, this is a file, the nuclear power plant file, and let me open this file. I think it's better. I downloaded that file. This file is also very important one. Let me see what is this opening. Maybe it takes some time. It's opened, and that file is this is nickel. Go through about this is also very important page, I can say. We go through this and see how it says. And this is concrete, durability of concrete, and I think concrete, curing of concrete. So durability we discussed yesterday, so it's not very important. And I say let me see same file or different one. So this we had discussed, so there's no need of this file to open again. About this is also a big file, and this is a paper actually. Basu Prabir, etc. Formally it is an abstract. We will see how does it work. And you can see a nuclear power plant involves complex engineering structures. That's true. And there are significant items of structures, systems and components. Structures, systems and components important to safe and reliable operation of NPP. And NPP means nuclear power plant. Concrete is commonly used civil engineering construction material in nuclear industry because of a number of advantageous properties. Nuclear power plant concrete structures underwent a great degree of evolution since commissioning of first nuclear power plant in early 1960. I'm just giving you a background so that we remember what to do. Increasing concern with time related to safety of public and environment and degradation of concrete structures due to aging related phenomena are driving forces for such evolution. Concrete technology underwent rapid development with advent of chemical admixtures of plasticizers, chemical admixtures of plastic and silica fumes. Application of high performance concrete HPC developed with chemical and mineral admixtures has been witnessed in construction of NPP, that is nuclear power plant structures. Along with beneficial effect, use of admixtures in concrete has posed a number of challenges as well as in design and construction. This along with prospect of continuing operation beyond design life, especially after 60 years, impact of extreme natural event as in case of Fukushima nuclear power plant accident, human induced events, namely commercial aircraft crash like event September 11, 2001 has led to further development in the area of nuclear power plant concrete structures. Now this paper which I am going to discuss with you is not mine, somebody else. Present paper I is providing account of evolution of nuclear power plant concrete structures in last 2 decades by summarizing development in area of concrete technology and construction techniques, design methodology, maintenance and aging. This is what we will discuss, and this is an abstract only. And this says here Mr. Basu, Engineer Basu Prabir, Levi Piera, Nasuda J. formerly in Atomic Energy Regulatory Board, India and International Seismic Safety Center, IAEA Vienna, Electric, Sci de France, Oak Ridge National Laboratory, USA. This will discuss about that one. Let's scan it first from the page. That high strength, high performance concrete, and then is fly ash based concrete, and of course there are some technicalities, and I will not go into details of that. Self compacting concrete, construction, and then mixing method, transportation and placement, curing, and then designs and verification of concrete structures, and major evaluations from generation to generation, and then it is ultimate bearing capacity of containment structures. I will just go through this only for reference. We cannot go forward, and you can say likewise, references and technicalities, earthquakes, and the seismic response analysis, and all that is given here in this. Continuing services of NPPS and degradation considerations, operational experience, aging management, and you can say likewise guidance for long-term operations, candidate concrete research topics in support of long-term operation, summary, and I think that is references only. That's going to be end of that. So just background I gave you. I'm now jumping to quality file, which is now it's very important file. Every day I'm trying to do amendments to this file, keeping in view my own thinking as well as what should be done. It's very important point. We have to be very serious about this. As an engineer, I'm saying I'm very ordinary person with very low profile. I prefer to live in low profile, and I don't show to everybody what I am or not, because it's no use. One has to always live in very low profile. It's better because you have to work. That's the important point. Work doesn't need any profile except what you are. I'm not admiring myself. It's not question admire. I'm just saying, okay, whatever it is, but I want to serve this earth. I want to serve what God has produced. That's my aim. That's my objective of life, and not now. It has been from beginning. My understanding is a little different than what conventional understanding stands for. My understanding of engineering and my understanding of society and this world, maybe all these vary in approach. I am not conventional person, and I think originally. And that's the reason that I sometimes I move very slow, or sometimes I move very rapidly. As far as my career is concerned, it's not secret. Again I say I am ordinary engineer. I don't claim that I am expert. Though my certificates say you're expert. No, I don't say. That is referral. That's only a reference. You can say it's like a reference expert you are or I am. That's only for measurement. That's only for, you can say, estimation purpose or valuation purpose. Because knowledge has no end, everybody knows, and particularly in engineering world, knowledge is always limited. I worked on sites, I worked in engineering coordination, I worked in, you can say, technical areas as well as in contract areas. I did some bad writings as well. I made mistakes in my life, and that happens with everybody. And mistakes, actually, we say mistake is not a mistake. You can say it's not. It's like error, error of misjudgment, error of judgment, or thinking it is right, it becomes wrong, or thinking it's wrong and maybe it is right. It's process of learning that's important, but learning should not be kept to your mind, kept to your work. It should be applied. If I learn something during application itself, then I should improve my work. And if I get some important information from some source, then I should apply that information on my profession, because nobody knows everything. Everybody knows nothing. Somebody knows something, you can say. So what I say, active quality performing application, I have written here, active quality performing application. Now, performing is very important here. I say active quality, it should perform. It should not be only in letters, it should be in spirit also. Then I say SHE. SHE, though you may say it is related to occupation, it is related to occupation partly, not fully. Safety during work, that's okay. Occupational health is required, occupational safety is required. But in totality, safety, health, and environment are also related to quality. Because your work should also be safe, not only work during working, your building during concreting should be safe, it should be safe during its entire life when it serves. That's what I mean to say. SHE is that one. That is reason I write SHE with quality. Because your work that you deliver, your good you call it, you can deliver, that should be safe. That should serve safely during entire life of that product, or you can say during durability of that product. Durability is very significant word here because it should work with same efficiency, intended efficiency or intended life. It should not degrade, or you cannot say now it is old, it doesn't perform. Yes, there is a limitation of performance, it is agreed, but it should serve with good safety, good service, and good health. It should have good health, and it should help others to have good health. And with such conditions, created conditions, environment should be becoming. That's what is written, active quality performing application. An application has no limit. There can be any number of applications, whatever number of applications, group of applications or major application, that cannot be defined. It depends upon enumerator what it says, what writes. Engineering approach on designs. It is very important phrasing. Engineering approach on design. Approach. Designer's approach is always very significant. Design is overall act. What designer thinks, what designer contemplates, or what is given to designer as information, and what is vision of designer, and also cost constraints, time constraints, use constraints, degree of requirements constraints. There are so many considerations, so many parameters that require to be considered, and that's why design is also a kind of, you can say, variation, the kinds of variation where every person has some approach, and that approach varies from person to person. Engineering approach means we have to apply power of mind on designs. Design is not simply a process. You cannot consider it just a process. Design is based on intuition, occult, etc. Sometimes processing is necessary if one's intuition is clear or occult power is clear. What is your dream? You have decided that based on whatever consideration, architectural consideration or structural consideration or future of that consideration. We cannot simply consider one point and decide. Various points are involved. Economy is involved, quality is involved, time is involved, long-term use is involved, change in society is involved, social changes are involved, or something becoming obsolete in future, that is also involved. Engineering approach is very important. You can say it is preliminary consideration as well as a primary consideration. It's dictating consideration as well as decision making consideration. It's economic consideration as well as evolutionary consideration. Because engineering is widest spectrum in life along with health sector. No country can say today we can move without engineering because engineering works everywhere. Therefore, design is very important task. Design goes in many stages we know, it's not one stage alone. Those who talks of designs, of constant designs, they are designers of course, but their design is based on given information. But what I'm saying is original design. This means conceptual design, which means contemplation. What is vision for something? That is most important. And then we can say after that vision, after that unclear picture, we can enter world of feed or even pre-feed. Feed, that is not written here, but you know what feed means, F-E-E-D, and that is front end engineering design. One is front end, other one you can say rear end. I'm just giving my own thought. When I say front end, means we have not entered body of the design, but it is front end we can say. Then we have got to rear end, and this travel distance from front end to rear end has some volume, has some dimensions, 3 dimensions, and those must be measured properly. Those must be given space allotment of our considerations. That is very much important. If we understand front end, we must also understand what shall be rear end and what should be accommodated in between two ends. And that's where design works. And when design works means our work on site acts, goes. Design means work on site, in fact. If design is good, work on site should be good. You have to take both together. Manufacturing should be good. You cannot keep away construction or manufacturing separately of design. Design cannot be isolated from manufacturing and construction. We have to understand this family relation. If those who think it's not my job, they are not perfect engineers, I should say. If designer thinks construction is not my job or manufacturing is not my job, then I should say there is some deficiency in educational level. You cannot keep yourself off from work, practical work, physical work, or your design work. Both must move together. Of course, there is a sequential difference. Who comes first? Everybody knows design comes first. Design is soul, design is structure, design is power. If design does not come first, you cannot work. Or if you work without design, then you work as fool. That's what I can say. It may not be necessary that design is a formality one, it can be in your mind also. Sometimes when there was no professional working, our artisans, our craft persons used to think and design in their minds without calculations but by experience. And they used to produce certain structures, maybe those were considered excellent. And now we say these were not economical. But design worked in their minds. Every person has got some design mind. Everyone has got, of course, with percentage variations. Even if a technician works like a mason, like a carpenter, or like a welder, or whosoever does some creative work, I can say, creative work I'm not talking process. That person, though not education wise, diploma or degree, but by learning, by experience, that person works on some assessment, some experience. And that's also a part of design. You think on what should be done and you think accordingly. Maybe you do first time it's mistaken, second time you improve that, third time you say, oh, I've done it and I have produced so many pieces. So that's also a part of design and engineering, I should say. We cannot go against that. It may be design in thoughts, design in contemplation. It should be. So that's what we say. We have to understand analytically definition. We have to redefine every time. We cannot say today we learn this, it's permanent. Permanent, nothing is permanent except that our views keep on changing and our materials properties keep on changing, and from child to old age we keep on changing and changing and changing. So it's a kind of assessment, you can say, for working considerations. All these points which I am sharing with you, this is also assessment process. I'm not saying everything is perfect in this case. Nothing is perfect. And it can't be perfect. Perfect itself is mistaken. So we have to understand these facts. It's very, very important. Just a minute, let me put off switch. So my dear friends, what I am stating here is your statement. It's actually not my statement. This statement is very raw, but always something starts with raw. So this active quality performing application, SHE and engineering approach on designs, manufacturing and construction, which I say redefined. I say redefined means every addition is redefined or every deletion is redefined. And I keep on contemplating every time what should I do, because I'm not at, you can say, end of thinking. Don't take it philosophically. Engineer's job is thinking. If engineer cannot think, then nobody else can think, I think so. Engineer's thinking is important because engineer has to create. There's a difference. Only science in world is engineering in which changes are affected. Engineering changes are very rapid, frequent, and engineering keeps on changing. And that is what is engineering. We cannot simply say today what is acceptable, that shall be acceptable tomorrow or after lapse of many days. I'm just giving this as a reference. Changes in engineering are a must. Only profession that demands changes is engineering. All other professions are set, cannot be remolded. We have to take this point into consideration. You can see software engineering. Every day you can find update on softwares. Same way, every time we find update in engineering methods, engineering world, engineering process. And that's where we can also say quality is impacted upon. And we have to assess every day, every time when you consider something. And that's why when changes happen, mind has to work. And changes happen because of mind work. Sometimes changes may be good, changes may be bad. That depends on where application is involved. We are assessing here working considerations. Because important is work. Work everywhere. Work means physical work plus thinking work. Theoretical work plus practical work. Both are combined together. Both are related to each other. And quality is soul of work. Just like we say we have a body and we have soul together, body and soul must work together. Or we can say in our language, mind and heart should work together. Mind and heart should work together, that is requirement. Same way, Body and soul must together, that is requirement. And we also can say when quality comes into question, quantity is automatically included or imported, because when quality exists, quantity exists. Without quality, there can be no quantity, and quantity, if it is without quality, it is nothing. It is nothing, it is only material. So, what we say in our country, I'm talking particularly of our country, and that's why it's written quality in Bharat, India. It doesn't mean I'm talking about Bharat, India only, but in this case, particularly, I'm very serious about our system, about our standards of quality or achievements on quality. Quality in our country is well known that we are, due to our lack of seriousness, we are not much advanced in quality. We lack, openly I am saying this, quality in Bharat, India is not as it should be, with of course certain exceptions. I cannot say 100% it is, but there are some areas where we have good quality, or you can say where other countries have best quality, we have good quality, you can say. But in general, in more than 98% cases, our quality is a question mark. We have to think of what we know about quality. Should we let quality system dominate, or works should dominate? There is a bifurcation. Whole world speaks of system, quality system, and we know we have. It's not thing new now. ISO 9000 we have, Sigma we have, and maybe more and more. I don't want to go into those details. Systems are fine. Systems are like our body. God has made our body. Body has systems, many systems. These systems work. But even systems work perfectly, why do we feel pain? Why we feel I have stress, I'm not healthy, I'm feeling pain, or I'm strained, I can't sleep. This is where we are talking of. We have works. And works are based on what? Works are based on certain theory, certain plan, certain designs. Works quality cannot be compromised. That's what it is intended to state. Works quality cannot be compromised, just in name of fragile quality system. Note this word, fragile. It is something I've added intentionally. Works quality cannot be compromised. When I say cannot be compromised, means no compromise. Can we stand on this phrasing? Just in name of fragile quality system? Can we say my system, this I am working according to system? I work according to quality system. But then why my product does not come to mark? Even if 2% or 3% product do not comply, this means something incorrect exists somewhere, and that can generate fragility. Quality system may fail. Yes, it may fail, and it fails because fragility exists, fragile it is. But works quality must perform. This means quality system and quality are not integrated virtually. And I say works quality must perform. What do you mean by that? Does it happen? But it does not happen currently in entire scenario. So what phrase is works quality cannot be compromised just in name of fragile quality system? Quality system may fail, but works quality must perform. Does it happen? If work quality performs, this means system performs, because work is final answer and not system. You cannot sell your system, you can sell your work. You can sell your work, you cannot sell your system, because system is imaginary. Work is not imaginary. We say it is ISO 9000 or sigma based. Okay, you have, but that is not seen. I cannot say this item is ISO 9000 system. This is a product. And when there was no ISO 9000 or when there was no formal quality system, manufacturing was done that time too, construction was done that time too. Companies used to work that time too, and everything used to operate better than it's operating now. Now we have bound ourselves with something which is not perfect. Do not take it as criticism. I'm just trying to understand what did we achieve by quality system. It remained as a showroom only, or is it effective? That is the point. If it is a showroom, then I don't need this. It's effective, then my product should be effective, my product should be quality. You can consider in your survey, go to market, check whatever products you want to check, what percentage of products comply with quality requirements, and you will find all system claims, oh, we are quality system. Every company claims, I am quality system. I am this certified, I am that certified. But products do not fit in like that statement. Oh no, this product has this defect and this product has that defect. This means system has no correlation with product. If system has no correlation with product, what's function of that system? Is it only document? You want only prepare document and keep in files for audit purpose, or let consumer audit product? Which is better? If you think I have certificate, this will audit it internally as well as externally, all works in my company are done. But what about consumer or user, customer? What about audit of that customer? That customer never audits because that is innocent. Therefore, it's very important point. We have to answer question, what is final, and that is work quality. Work quality means activity, it means product, character, it means construction, standard, it means product standard. Those must be met, and not on papers, in physical form. On papers, it can be done very easily, but in physical form, that is where testing is done. So we can say quality control, which is a part of quality system, should be weighed more than system itself, because system has not delivered perfect standards. I have witnessed many activities in system, and I think human angle dominates, and sometimes they say, okay, it is formality, and if people say it is formality, then I really don't accept that. System does not mean formality, system means to be done. To be done. We cannot simply move away by saying it's formality. That is wrong. How can we leave something formal? We have to be very serious about product. As Sigma says, where only few items are acceptable which are rejected out of millions. Does it happen practically? Only few items in millions, if are not to standards, it is acceptable in millions. But does it happen? Productions, in manufacturing, in construction, how many million items did we check? How many million? Got somebody record? I think no. Nobody got any record. This means that is only fancy statement. Is engineering a fancy word? Is a modeling or it's reality? Thus I say reality and modeling are different. Real world where quality is measured by customer and ultimately customer only curses, nothing else. Preliminary consideration I say is what? Where does quality exist? You may say every day I raise such questions which are relevant. Yes, you may say questions are relevant, but sometimes, when something pinches or something doesn't look nice or to your taste, you may say that. But when you go into depth of every issue, we find that something is right. People have decorations, very good packages, packing system, delivery system. Of course, up to that level it's fine. But I'm not buying a material for good package. I want good material. Package is not my requirement. It's same thing. Contents of book must be excellent, not book cover and not standard of pages. Contents make a book, not its cover, not its, you can say, quality of page. If contents are wonderful, book is wonderful. So simple. I am interested in book's content. I am not interested in its cover. I am not interested in what a standard author has. A book has good content, excellent content, attractive content, useful content. Author is very powerful, I can simply say. I don't want qualification of that author, what author says. It's power of writing, it's power of thinking that makes a book. That makes something. So preliminary considerations are many questions. And it is where does quality exist? Again, question is, I can say quality exists nowhere, but it should exist everywhere. It exists nowhere. Nowhere means quality means what is required to be done, accepted. For that purpose, it happens that quality is not generalized, it is specified. It's not uniformly applicable. It is, you can say, activity based applicable. On activity it applies, on operations it applies. It varies from one operation to another operation. It varies from one activity to other activity. If question arises, where does quality exist? Then I answer, I give response equal to could not find anywhere, unfortunately. Because if I find it, then I should not talk like this. I should not waste my time and your time on this. And it's only for not you, but also for others. Engineers are very important element. Engineers are very important unit, you can say, entity in society, everywhere. And if engineers do not care for quality, then you can say it's havoc. It is havoc, really. It results in devastation of everything. I'm not considering engineers as professionals only. It's not professional alone. Here engineer is something which cannot be clearly explained, because engineer has to make present, has to amend past and has to build future. Or you may say, engineer is responsible for sustainability. Very common word we use these days. Sustainability everywhere. If engineer does not care for sustainability, nothing can happen. We can spoil everything today. We can consume every material today. My question to everybody is, did you find what I'm asking for? Or can you find for purpose of deliberation exclusively? And that's where point lies in. So we can say we have one question here. I have put in red lines itself, and red lines to be resolved. Important part is red lines to be resolved. Can we bring working environment to quality requirements? Can we bring working environment to quality requirements? And that is where secret lies in. Environment where we work in team or in groups or in isolation or as independent person, that environment is very significant from every viewpoint. That environment cannot be taken for granted. That environment is very, very important. So what we state about that? And I should say, in that case, let me blow it up. I've blown it up now. Okay. So my statement here is certain red lines that must be turned green, and that must be a must. Certain red lines that must be turned green because we have to move, and red lines stop me. I have to turn green, and that turning is a must. That means I have to pass through amber light. If I equate it to traffic light system, red line, amber line, and then you have to go to green. Worsening state of quality of works and how to improve such mandated works quality to certain minimum required marks. That is one point we have to consider. Worsening state of quality of concrete and how to improve such mandated quality to certain minimum required marks is another point we have to confer. Worsening state of communication and coordination during working on engineering designs and executions or construction activities. This is another point. Determined and dedicated role of engineers. Determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth. That's also one point. Can we do it, or we are incompetent, inconsistent societies and communities in engineering? Are we engineering force or incapable lot? These are only few points. These are not end. Shall we make engineering a quality force? Who shall decide about all such questions that are being faced in current scenario? These are certain preliminary questions. And now we have long explanations also. I'll go one by one. I'm just reading first for you. Means what is in my mind. That's very important point here. And that is engineers' detailed deliberations must. Certain questions are here as well. Dissemination of engineering information about quality requirements and how to transform using method statements. That is one part. Methods can be designed and drawn, stated for designs, for execution, for carrying out activities, as well as for rectifications, remedial, and for services. Methods means comprehensive methods and not selective ones. No work be carried out without referring to method statements, which must contain SHE and quality approach at every possible and convenient stage. What about contracts for construction? Should engineers know thoroughly? What about contracts for designs, procurement and construction? Should engineers know thoroughly? Do we organize to design quality contract, or do we go per lines decided by others? Should we ignore power and impacts on works, quality performance that contracts can attack in designs and prosecution? Do our engineers have interest in contract design, drawings, activity, which always remain very complex, which always remains very complex and certainly impacts on contract performance and contract related disputes? Are our engineers, those interested in designs activities, not inclined to involve with construction activities? And if not, what are valid reasons? What issue that engineers do not incline to work coordination activities that impact on quality of designs and quality of construction? Should we respect project contracts, or we should move without such contracts? What about major materials being concrete in structures? What about major materials being concrete in structures? What about major materials that are considered often permanently included in structures and buildings everywhere on all projects? What about engineering materials being used to produce various hundreds parts goods in manufacturing? What is provision by government to force productions and constructions be delivered with quality compliance? What can be certain reason that quality requirement is being ignored by nation? What reason does exist that engineers are not able to conduct required contributory roles towards quality domain? How can quality be controlled and systems worked out for best organization in this regard? What should be required active role of engineers? What should be required active role of engineers in all branches of engineering? What should be role of actively performing workers to handle instructions in this regard? Is quality compliance requirement so difficult that professionals ignore it, or they remain under pressure? Can we people digest bad quality? Can we people digest bad quality in goods, products, and in construction? What is the role of government in this regard? Should government not add its active role towards quality? What should be role of customer or consumer or end user in this relation? Should end user or consumer or customer not be awakened to know quality requirements? We have to establish quality system and quality procedural approach while conducting designs, planning and prosecution of executions of work. Who shall do it? Shall we keep silent and allow as it has been ongoing, or do some concrete acts to encounter bad quality? Answer is that it is pragmatism of engineers that would handle it. Not only civil engineering but also all other engineering operations must be oriented towards achieving quality objectives. It's never too late, for development has to go on continuously, by which satisfaction must be obtained while performing engineering activities in organizations. Management that only talks of results. Management that only talks of results without heavily or intensively weighing quality approach and sequential results cannot be relied upon. Should we apply only management principles or we should rely upon real organization methods where set goals, pertinent quality requirements are defined. Without achieving set quality requirements, no development can be sustainable and durable in long run. As is often said that civil construction matters a lot all over during total development scenario, where civil engineers works as ab initio first principle starters. The professional must be strong enough with determination and commitment to give quality as intended to be delivered with product, so that other entrants may for sure follow suits respecting other disciplinary disciplines or branches. Engineers have to decide to determine forever that quality cannot be taken for granted and that have to work for engineering demands and requirements. First essential is that civil engineers must care about professional requirements relating to projects where major structures are included permanently, which could be of significant value of being constituted in framing RCC components, structural steel components, precasting components, and all other considerable elements that add to structural structures, for example, remedial actions, modifications, etc. If structure is taken quality care of, all other components or items are secondary in considerations, but can be taken care of if structure has reliability modulus inculcated. If services are also included with the structures, additional care must be resorted to for engineering coordination, because coordination works is a specialized job on such structures. And it's also true that it's like an additional expertise that every engineer does not possess, and no academic branch or subject teaches it. This is learnt only by experience and by involving oneself in multidisciplinary works without having any second thought. Therefore, it is emphasized that coordination, true and effective approach must be adopted as an essential if quality is required, destined to be affected on structural arrangements from every viewpoint. And it's also true that many changes are effected during construction or during production of working designs, if procedurally coordinated for engineering. We all must contemplate intensively related to quality of works, requirements, or else quality systems got no meaning at all. I have written something in Hindi also. You can read if you wish. I'm not going to repeat it because it's not exactly what I have written in English. These both have different. And of course, this Hindi is not exactly what it should be. So I'm leaving it to you. No seriousness has been observed. I'm just further commenting on that. No seriousness observed among engineers from all branches about quality requirement with no known reason. Why are we so serious in quality regard? Why are we not serious in quality regard? That's another question always. No material or product in our market is available that can give or deliver quality performance. Yet, quality mark is owned by material or product manufacturer. How is it possible? This means that quality certification is not perfect, but just a decorative formality, whether or not private or government. Quality exists nowhere but in lip services only, or in publicity just to deceive purchasers and to promote business or industry. I am sure that engineers have forgotten quality or they did not study about what does quality mean. And universities as well institutions have not been capable to inculcate quality mandate into studious minds. Every organization is certified by quality system, but existence of quality is poor, and only tag is that such and such is quality certified. Government least bothers because it doesn't care for engineering and engineering products, but only for profits and gains from corporates. For government do not bother about quality for people's lives. Companies least bother because they are commerce and business oriented and believe only in shortcut earning methods. No long term vision is owned by majority owners, and for them, if product fails in performance, consumer shall buy new one. Professional engineers never ever bother because they have gotten no independent standings and are unable to fight against abuse of quality system and tacitly support misleading publicity. And even after such carelessness in works, they call themselves professional engineers. Engineers are not well trained to an extent quality is concerned because quality cannot be learned in theory alone, and also just computers use cannot bring quality input into products, whereas quality is a basic requirement and must be in minds, hearts, and in patience. Thousands designers and executives are available, but never deliberate quality, for which reasons are unknown, or they run away from accepting facts. Is this what we do call engineering? I call it engineering failure, and for sure, engineering abrogation. Recall, really fed up with nation's continuous silence on such issues. Top class academically educated professors and doctors avoid conferring on quality, forget about graduates, and thinking of so many trillions economy, let's say $5 trillion economy, imaginary idea only, and for sure it's fictitious only in terms of engineering because economy is generated as assets by engineering industry. Shall we reach this target without quality inclusions? How about I do not know? Only fake people can answer fake, but quality, reality, quality answer can come from professionals only. Only fake people can answer fake, but quality related answer can come from professionals only. Civil engineering domain is located at top in delivering unacceptable standards, whereas it should deliver topmost durables. Civil engineering products are meant for use during decades, to come, while other products are used only for few years. This means quality responsibilities lie on civil engineers, including structural engineers, but it doesn't happen in reality. And we have been continuously delivering short life structures for our future and present sustainability and wasting use of nature and its delivered raw materials. Engineers have become only design oriented and no commitment robots rather than being practical and pragmatic professionals. Design can itself not import quality for permanent inclusions. Institutions have become non existent because they are not serious in performance and just act as showrooms. Government is non existent because it has got no quality system in its approach and performance. Institution of Engineers India has failed in doing its job, and all other NGOs, societies, institutions have entirely become septic. Engineers do not have a communication and coordination skills. Engineers do not have communication and coordination skills, which are first stage activities to know about what is required to be done factually and not just by hypothecation or by speculation. Engineers do not have struggling and encountering skills currently, for which reasons are unknown. But it's also true that without engineers, development stops. Engineers have become toys in hands of government and industrialists, which amounts to an unbecoming quality development state. Youth or budding engineers must learn, or else no one shall call them engineers. Old engineers have lost their quality practical systems. Those who never worked in field decide about education specifications in engineering. Those who never experienced field decide about codes. Professors are only theoretical tutors and not pragmatic field runners. Just achieving degrees are not adequate, even if one is a doctorate. Experience that is to quality based must be a must. Think about quality always. Communication and coordination, most significant disciplines and subjects. So, it's what I will not go further into this document because I have ended only up to this point, and then we can say it's really, I think, explanatory mode that I tried to get you. It's important one. It's long discussion. It's long paper, of course, and we have to be very serious on this issue. That very important point is about communication. Here is communication is very important. It should not be misunderstood. First of all, communication is part of our life, and we have to be very serious about that matter. I'm not trying to speak a translation to Hindi because I think, first of all, it doesn't go to everybody, and this talk is meant for whole world, not only for our country. I'm making name of our country because I'm serious about that. It's otherwise this is meant for whole world. So when we talk of something that is communication, then we can use medium of English for purpose of communication, but it doesn't mean that I don't respect. I respect, and my communication coordination style is different, and you can say your information must reach to a person who requires that. If I don't do that, I make a mistake. That's why I've taken, you can say, communication and coordination very seriously. And nowadays it's also seen that, not only seen, it's evidenced that electronic system has actually spoiled communication system, in the sense that we do not respect hard copies, we do not respect paper, we do not respect writing. I'm not saying all are like that, Our writing skill has gone, our good speaking skill has gone. People used to say drafting power sometimes. Drafting power. What is drafting power? Maybe those people who are new, who are computer generations, they do not understand what is that. When I say, everybody knows that what we speak is not exactly what we have to write. A speech, first of all, cannot be withdrawn. Whatever you speak, if once you have uttered those words, we cannot call them back. We cannot amend those. But when we write something, first of all, it's time consuming. You cannot write whatever you want to write. You cannot write anything. You have to think on that, but when you speak, you think, of course, that time too, but it's not that intensive. Means you can say, okay, I know this, or it happens like this, and later on you say, oh, I didn't mean that. It happens. Oh, I did not mean that, and my statement has been twisted or has been taken this way or that way. But when you write something, you cannot do it that way, because writing is a power. You see, communication means speaking, writing, rewriting, or you can say reconfirmation, acceptance, etc., etc. People now, they sell communication skill. Oh, we will make you a good speaker, public speaker. Question is not you're a public speaker, you're not a public speaker. Question is what you think about speaking. What contents in speech you bring into. If your contents are powerful, available, well, I think you can speak better. Speech doesn't mean only speech. This means matter, this is weight of what's your subject and what's your issue that you are talking about. And that's very important. And if you don't have work at home and you want to speak, you may be an intelligent person, you have experience and you can improvise answers, that's no problem. You can give immediate answers if you are expert. And if you are not expert, then you have to prepare and then speak. But here point is communication and coordination, and it applies at every step. Particularly in engineering, it applies at every step. And I'm again giving evaluation of my statement that engineering involves this you can say communication and coordination domain, you may say, or may not be domain, let's say ordinary requirement, but it's very significant, important, you can say method, without which we cannot do anything. Writing document, final document, informative document is an art. It's a personal art, a private art. Speaking is not exactly an art. Yes, speaking with your mental state. If you have used mind in speak and not copied from somewhere else, then you can talk differently. You can speak differently. Quality in speech, quality in writing are also significant. And in engineering works, when I am saying quality is required, this means specific writing is required. In engineering, specific writing is very significant. Because we do engineering, we have to write specifications for every work, every activity that is done or that is conducted in works. Specifications are available in designs too, in forms of design procedures, in form of method of designs, in form of coded applications. In designs, procedures are there, but those are serious procedures. Those are not text procedures. Those are systems procedures. Those are framing procedures. Design is very intellectual job, very, very professional job, you can say highest level of professional, because we have to calculate in unlimited way So many formulas are applied, so many techniques are applied that even sometimes we forget what we have applied, so we have to write what we do so that it is recalled easily by everybody. Of course, we have softwares, but softwares are only softwares. There can be errors in software also, and that error can be realized by experienced designers. Of course, budding who have no experience in manual working, it's impossible for them. But since those who have manual work as well as computerized work, they can know what is right or what's not right. Well, and because I'm taking this issue of communication coordination in my talk, it's of course very extensive issue and we can not go without this in whatever work we do. But I would just say that written document is a must for reference. A written document is a must for reference, and we should avoid very, very long talks because these are all futile. Specific talk, pointed talk, question and answer talk, that is more important. Long talk means nothing, repetition and waste of time. Specific talk is very important. Therefore, we can say we jump onto contracts in that case, and contract is actually very important, significant answers. Contracts, when we say it is something solid, contracts we have to reach a system. Of course, it is written document, but it is full of requirements. If there is no requirement, there is nothing as contract. There is requirement. There should be. What should be the role of that requirement? Who should do that? Whose liability? Whose responsibility? Whose legal liability, or you can say whose long responsibility? Contracts are qualified to be explained. Contracts are explained properly and designed properly because contract is a binding document, a binding agreement in writing, and that means one is liable to someone and one has to pay to someone else who is liable. Both points are available, both points are applicable. So contracts is very much part of quality. If contract is qualityless, you cannot perform with quality. Therefore, I would say it's very important point that people should care about contracts. And that's where I bring always in this talk that when we say quality in India, we question about all these points and we say that how can we solve that? Answer is same. We have to depend on, as is given in 5 number here, that contracts for construction, and here contracts are required professionally and contract should be professional. It should be completely professional without any deficiency, and it can depend on experience how best contract you have drawn or design. I should say contract design is on top in construction world. You may use FIDIC, you may not use a FIDIC, that is different. But what you have to do is what is in your mind, that is very much required. As I say, contracts, it is job of engineers to be very frank to design a contract technically. Its language can be given legal shape later on, but what you have to do, that must be given reference and points. It is job of engineers to devise, to design, to draw contracts, because only they know what is sequence of procedures, what procedures are involved, and in what phrasing this can impact quality. Because you have to give this contract a physical shape, not from yourself but from project. It may be design contract, it can be construction contract, it can be engineering, procurement and construction contract. And these are all voluminous activities. Engineer and contractor, when they work together, it is expected that they should trust each other contractually. If they trust each other, this means a positive, a good and acceptable, brightful environment is created. And if they don't trust each other, if they don't, it is then different. It's then money value only then, you can say, otherwise it's not money alone, it's so many other factors that come into play. Contract design, contract drawing is very easy if your points are clear, and it's very difficult if you are not clear. But we should not forget that everyone has got its interest in business, its stake interest, business interest, and when so many interests come together, then quality interest is faded, is diminished. But we have to mandate it, because quality cannot be mandated separately. You cannot measure quality separately, you have to measure product, and if you accept product, that is final measurement, that you accepted that and I gave you this. Of course it is general, once you do work you cannot change quality, you cannot do anything, so we have to be very serious about this. Can we handle contract? And that is very much required part of engineering and construction, because contracts cannot be thrashed practically, it cannot be thrashed. Construction contracts are very significant from viewpoint of designs, because destiny of designs is always construction. A success of design, success of designer depends on success of worker on site. I am not saying engineer alone, I am saying workers on site. How workers prove, how workers produce, what knowledge they have, that's also a big question, because everything cannot be examined all the time. Our technicians should know what is required. Of course they cannot understand everything in technical way, but convention they understand, and practice they do understand. Contract should be speaking one, it should not be silent one. And when we say speaking one, it's a question mark. When these contracts are purely technical and purely engineering based, and we say this should be speaking one, this means this demands a lot. Speaking one contract, not silent one, means you cannot expect a contract that you have to think on everywhere even after contract is done. You cannot leave it to individual all time. Okay, in certain rare cases you may say, but what you do every day, you cannot do same thing whole day, every time. But you have to accept variance also if these are within quality limits. So let's say, what about contracts for construction? Should engineers know thoroughly? And what should be answer? I think they should know thoroughly. Not only thoroughly, practically as well. Contracts should be structured one. Contract should be serious one. Contract should respect both employer and contractor, of course third party or independent party, that's engineer. Contract should speak a lot. Contract should be serious and easily readable and understandable. We should make contract that invites interest of everyone. If explanatory is speaking clearly, it speaks clearly of contract, then everybody can learn something from whatever contract. We'll talk a lot on contracts and all this in coming times. Then what about that design, procurement and construction projects, which we generally say this EPC based activity, or this is EPC based contract. And when you say EPC, you know clearly what's meaning of EPC. Engineering, procurement and construction. Where engineering is involved, where procurement is involved, and where construction is involved. These items, engineering, procurement and construction, are having very vital meaning. Very, very vast meaning it is. Stars to pick. We shall discuss that one. It's very important one. Our purpose we cannot fulfill in one day because contracts is itself a domain. And not only contracts, we have to understand. We have to understand contract and we have to understand its aftermaths. When we adopt some contract, there can be many secrets. Those secrets are important to learn. And learn by experience and not by any book. You cannot just say, I have got this book, I say. Until you see yourself on sites, on what happens, you cannot realize facts. You cannot just be coordinational theory wise. You have to be practical also. Therefore, we can say, when I say quality contract, what does it mean? Do we organize to design quality contract, or do we go per lines decided by others? Well, I don't accept that we have to go on lines decided by others, because situation in every year, situation scenario changes, and thoughts expressed by people also keep changing, and this is what society is. And when we say contract, contract means job has to be done. That's what contract is. Job has been to be done with, of course, given conditions. Somewhere, sometime be from honor, and sometime from those who have to follow honors. Very important point, and cannot be taken for granted. Again I say, cannot be taken for granted. When we say, again I say, do we organize to design quality contract, or do we go per rules, per lines decided by others, or should we ignore power and impacts on works, quality, performance that contracts can attack on design and prosecution? Question is that, do our engineers have interest in construct design? That's very important part, because it cannot be taken off, it cannot be counted, and it has to be understood in letters and spirits. Design activity always remains very complex, and certain impacts on contract performance and contract related disputes. Are we engineers, those interested in designs activities, not inclined to involve with construction activities? And if not, what are valid reasons? This will take up later on. I'm just jumping back to file here. We have to talk of certain technical now, and that is where I downloaded some file. I'm not able to find that one, and that is I don't know. I got it concrete. See, I concrete telecom, concrete say. I don't know where it is gone. In fact, I downloaded that one. Just very small paper, actually. Using downloads. It happens sometimes. I don't know why I get confused in this way. Let me see if I can get it. Oh no, not this one, not this one. This is not that one. Anyway, I could not find that. I'm sorry for that. Where's that? There's an update yesterday was filed. Let me see if I can get it. Really, it's not actually. Smart paper, nuclear power plant. Is it that? Page 31, this is same one. So this is not that. Let me see. 23rd January. 9 July, 9 July. I think I missed that one, right? I'll try it again. I think I missed somewhere. Let me go back. Now I'll discuss something about nuclear power plant concrete structures. As I discussed before, it's of course very interesting. Maybe I've not gone through this myself, but I think it should be interesting for connections of discussion. This introduction here says that first nuclear power plant was commissioned in early 1960. Construction of which might have started somewhere in middle of 1950s. Let me put on my battery first, though I'll forget. Just switch off. Let's go back and talk again, and it's really wonderful to talk like this. So it is starts charging now. Okay, it's charging, that's okay. And I take it like this. Let's say now first nuclear power plant NPP was commissioned in early 1960, construction of which might have started in 1950s. And it is on day of this paper, it says presently 437 nuclear power plants units are in operation in 37 countries with an installed electric net generating capacity of about 372 gigawatts. So this is site www.euronuclear.org. Okay, leave it now. Now further 64 units are under construction. Okay, leave it. These NPP reactors can be categorized into three generic groups: Generation 1, 2 and 3. According to Generation 4 International Forum, which introduced this terminology in 2001, Generation 1 consists of reactors built before 1970. That is Generation 1, which were built before 1970, these reactors, most of which are not in operation anymore. Generation 2, to those built between 1970 and end of 90s, is still in operation for most of them, and Generation 3, to those designed to replace Generation 2, in coming years. Actually, most reactors constructed in evolution of reactors from generation 1 to generation 3 led to tremendous improvement in safety features, especially for internal events. Nuclear power plant involves complex civil engineering structures operating in demanding environments that have potential to change level of safety margins necessary throughout its life cycle. Civil engineering structures are significant items of structures, systems and components important for safe and reliable operation of nuclear power plants. They perform their intended functions in two ways. Firstly, they house systems and components and provide required operating environment. Secondly, given an accident condition, they mitigate its impact confining radiological release within their structural boundary. It says, secondly, given an accident condition, this mitigate its impact, confining radiological release within structural boundary, respective structural boundary. Concrete is commonly used civil engineering construction material in nuclear industry because of a number of advantageous properties it has. Moldability, easy manufacturing process, uses of mainly locally available ingredients, relatively less production cost, good strength in compression, good shielding property against radiation, especially gamma radiation, etc. Distinct areas of nuclear power plant concrete structures dealt with in nuclear industries are material, concrete, including proportioning of concrete mix with chemical and mineral admixtures, fulfilling functional requirements. Design and construction of concrete structures covering behavior of structural concrete, constitutive models, fracture phenomena and leakage, impact of operating environment, analytical and experimental response of structures against earthquakes and extreme loadings, both static and dynamic, and operation and aging management. These three areas, which is area 1, material concrete, including proportioning of concrete mix with chemical and mineral admixtures fulfilling functional requirement. Number 2, design and construction of concrete structures covering behavioral of structural concrete, constitutive models, fracture phenomena and leakage, impact of operating environment, analytical and experimental response of structures against earthquakes and extreme loadings, both static and dynamic, and third is operation and aging management. These three areas of nuclear power plant concrete structures underwent a great degree of evolution along with evolution of NPP reactors from generation 1 to generation 3. Survey of transactions of international conferences on structural mechanics in reactor technology SMIRT, that is survey of transactions of International Tech Conference on Structural Mechanics. So structural mechanics in reactor technology, this SMIRT, structural mechanics in reactor technology, provides a good account of development in these areas over years. Deliberation on first area has been started in last 2 decades, so okay, this reference, highlighting more on Work on remaining two areas are being reported in transactions of SMIRT, reactor technology, okay, that is SMIRT, as I said before, it is structural mechanics in reactor technology. Present paper, this document describes evolution of nuclear power plant concrete structures in last 2 decades by summarizing development of area of concrete technology and construction techniques, design methodology and approach for continuing operation through maintenance and aging management of concrete structure. Material concrete. Now we are talking of concrete here. Very simple it is. I know this is not very conducive, but now in nuclear power plant, concrete mixes having different requirements are used. Concrete of different density, low, medium and high strength, normal, moderate and high desired durability, low permeability, wear resistant, etc. Conventional ordinary normal strength concrete. Conventional ordinary normal strength concrete NSC for structural use was first developed with basic ingredients: coarse aggregate, fine aggregates, hydraulic cement or ordinary Portland cement with water and water. Hydration starts immediately after mixing cement with water and produces cement paste or hydrated cement paste. Concrete at fresh state can be described as a suspension of aggregates in cement paste. Paste serves as binding agent that binds aggregates to work together as a composite material. Physical state of paste changes from liquid with suspension to a complete solid during process of hydration. This is Taylor 1990, Navelli 1996, Mehta and Monteiro 1997. Concrete is principally a three-phase composite material consisting of a binding media within which particles or fragments of aggregates are embedded. Bulk HEP and aggregates HEP, as we said, SCP hydrated cement paste, SCP hydrated cement paste, bulk hydrated cement paste SCP, and aggregates constitute first to transition zone between bulk HCP and aggregate. Transition zone is also HCP hydrated cement paste but of inferior quality than that of bulk HCP. Structural concrete of various types, normal concrete, heavy concrete and borated concrete were manufactured in early days of nuclear power plant construction using primary ingredients coarse aggregates, fine aggregate, cement and water, mixed design being done by volumetric method. Strength was considered as most important performance parameter in mixed proportioning. Durability was believed to be directly proportional to strength, and workability was assessed in terms of slump. Effect of high temperature on concrete has always spatial implication on safety of NPP concrete structures. There are numerous publications on effect of high temperature on conventional concrete. Work of Kanema has good coverage in this area. Investigated influence of mixed parameters and microstructure on behavior of concrete. At high temperature, it says investigated influence of mixed parameters and microstructure on behavior of concrete at high temperature. 5 heating, you can say 5 heating. It is cooling cycles with maximum temperature 150 degrees Celsius. Cooling cycles, 5 heating cooling cycles with maximum temperature 150 degrees Celsius, 300 degrees Celsius, 450 degrees Celsius, and 600 degrees Celsius. 5 normal concrete mixes without mineral admixtures having cement content of 325, 350, 400, 450, 550 kg per cubic meter with water cement ratio 0.62, 0.55, 0.44, 0.36 and 0.29 respectively, and a constant aggregate content were studied before and after heating. Cooling cycles. Measurements of compressive and tensile strength, modulus of elasticity and permeability were carried out on cylindrical specimens before and after heating. Cooling cycles. Complementary measurements of concrete mass losses and temperature field at various locations in specimens were also carried out during heating. Cooling cycles. Properties of heated concrete at 150 degrees Celsius. Properties of heated concrete at 150 degrees Celsius remained close to those of non-heated concrete. There was even an improvement of compressive strength for concrete mixtures with high cement content. All concrete samples underwent significant mass loss between 150 degrees Celsius and 300 degrees Celsius, mainly due to escape of great part of interstitial water and hydrates. Mainly due to escape of great part of interstitial water and hydrates, bound water, but maintained their mechanical properties on a high level in temperature range 300 to 600 degrees Celsius. Major decrease in mechanical properties, deterioration of concrete matrix generated from increasing concern for safety. Advancement in structural engineering, shrinkage of resources, and new economic considerations dictated necessity of development of workable and durable high strength concrete. A limited success of improving NSC was achieved using chemical admixture, plasticizers, superplasticizers, categories. Introduction of chemical admixture not only improved quality of concrete but also facilitated mechanized construction by pumping fresh concrete. High strength concrete was achieved with introduction of mineral admixture having pozzolanic characteristics. High strength concrete had issues related to durability. However, mineral admixture along with chemical admixture opened opportunity of engineering a concrete mix with improvement in its properties and per specified various performance requirements. This resulted in development of high performance concrete. High performance concrete mix is generally attributed to higher strength and durability than NSC normal strength concrete. Improved properties of high performance concrete is achieved by modifying microstructure, particularly that of transition zone. Such modification in microstructure is engineered by using chemical and mineral admixtures, appropriate grading of solid materials starting from coarse aggregate to finest one, and low water binder ratio. Mechanism which leads to desired modifications of microstructure has three components: reaction mechanism among ingredients, physical properties is basically related to chemical reaction among ingredients and related physical phenomena involved with hydration of cement paste. Physical process results in creating conducive conditions for reaction mechanism to happen through different actions during construction. So one is reaction mechanism is basically related to chemical reaction among ingredients and related physical phenomenon involved with hydration of cement paste, and physical process results in creating conducive conditions for reaction mechanism to happen. That is, physical process results in creating conducive conditions for reaction mechanism to happen through different actions during construction. Curing maintains satisfactory condition so that reaction mechanism can be completed to a desirable state by preventing moisture loss and maintaining appropriate temperature after placement of concrete. So we can say all these three: reaction mechanism, physical process, and these three have worked together here. I repeat, reaction mechanism is basically related to chemical reaction among ingredients and related physical phenomena involved with hydration of cement paste, and this physical process results in creating conducive conditions for reaction mechanism to work through different actions during construction, and curing maintains satisfactory conditions so that reaction mechanism can be completed efficiently to a desirable state by preventing moisture loss and maintaining appropriate temperature after placement of concrete. Further advances in concrete technology led to development of self-compacting concrete, which is also known as self-consolidated concrete. Unlike traditionally placed concrete, which is compacted with external energy input, namely vibrators, tampering, etc., self-compacting concrete is compacted or consolidated under action of self-weight. Self-compacted concrete is also a high-performance concrete mix with additional performance requirement of self-compaction or consolidation. Rheological characteristics of fresh concrete essential for self-compaction are filling ability, which is ability to fill all spaces within formwork. Passing ability to passing through obstructions of reinforcement, and embedment, and resistance to segregation, maintaining its homogeneity. Difference between traditionally placed concrete and self-compacting concrete is performance in fresh state, requirements, and same in hard state. Workability and durability are principal performance requirements considered separate parameters in engineering concrete mix for construction of nuclear power plants for last 2 decades or so. So we can say strength, workability and durability are principal performance strength, workability and durability. Now high strength concrete, high performance concrete mixes with admixtures was introduced in construction of nuclear power plant structure during last phase of generation 2 and being now used in construction of generation 3 nuclear power plants. Generally, two types of chemical admixtures, plasticizers, superplasticizers, and viscosity modifying agent, VMA, viscosity modifying agent in case of SCC only, are employed in concrete mix for NPP structures. Though high performance concrete mixes had been developed using silica fumes, granulated blast furnace slag, and high reactivity metakaolin, rice husk hash, use of silica fume and fly ash as mineral admixture is common in construction of high performance concrete was used in construction of Specs to NPP of France. High performance concrete was characterized by its low cement content, 266 kg per meter cube, and water content 161 liters per meter cube, as well as by use of silica fume and calcareous fillers. This formula resulted concurrently in high 28 days strength of 64.5 MPa and high workability. As compared to a conventional concrete, temperature rise was cut by 25% in a 1.2 meter thick wall, shrinkage and creep features were improved, and air tightness was increased by a factor 10. Air tightness was increased by a factor of 10. Delamination dome of Keja Atomic Power Project Unit 1 in India had occurred during construction. One key component of re-engineering of laminated dome was use of SF based HPC, silica fume based high power concrete of characteristic compressive strength 60 MPa and characteristic split tensile strength 3.87 MPa. Concrete mix design and construction techniques where silica fume were improved, taking into account experience of CYX NPP. M60 grade HPC mix for re-engineered Kaiga 1 dome was established by conducting a series of trial mixes. A detailed R&D program was undertaken to develop suitable HPC mix for Indian NPP. Containment structures of Kaiga 2 Rajasthan Atomic Power Project Unit 5 and 6, and Tarapur Atomic Power Project, Unit 3 and 4, were constructed with similar HPC. It was studied thermal gradient and mechanical behavior of silica fume-based high-strength concrete at raised temperature up to 200 degrees Celsius. 4 groups of specimen, 2 HSC with and without polypropylene fibers, 1 lightweight aggregate concrete, and 1 NSC normal strength concrete, were subject to identical testing conditions that determined compressive strength, modulus of elasticity, and splitting tensile strength before and after a heating cooling cycle at 200 degrees Celsius. Thermal gradients were significantly lowered. By adding polypropylene fibers. Thermal gradients were significantly lowered by adding polypropylene fibers to concrete, 2 kg per meter cube. Polypropylene fibers did not modify residual mechanical properties of tested high-strength concrete. Neither compressive behavior nor tensile behavior was significantly modified by adding polypropylene fibers. Neither compressive behavior nor tensile behavior was significantly modified by adding polypropylene fibers. Thermal gradients were greater in lightweight aggregate concrete than in HSC with normal weight aggregate. Thermal gradients were greater in lightweight aggregate concrete than in HSC with normal weight aggregate. NSC presented lower thermal gradients, that is normal strength concrete presented lower thermal gradients than high strength concrete. Compressive strength was reduced by splitting tensile strength, appeared to improve when lightweight aggregate were used. Furthermore, residual mechanical properties of normal strength concrete were better than that of other tested high strength concrete. Effects of temperature on structural quality of silica fume based HSC at Czech Republic, Slovakia and Penly, France, nuclear power plants. Strength, elasticity, modulus and deformation of concrete are irreversible influenced by temperature. Strength, elasticity, modulus and deformation of concrete are irreversible influenced by temperature, elevation, mainly to 100 degrees Celsius and 200 degrees Celsius. Concrete exhibits a pronounced softening as a result of elevated temperature exposure. Pore structure coarsening at end of recovery period after 100 to 200 degrees Celsius exposures results in significant strength decrease of cement paste and concrete. Rapid cooling after temperature elevations evokes equal and irreversible structural quality deterioration of concrete and cement paste. Self-curing of concrete and cement paste after short and long-term recovery at 20 degrees Celsius does not contribute to structural integrity improvement. It's very, very important research point. It says strength, elasticity and modulus and deformation of concrete are irreversibly influenced by temperature elevation, mainly to 100 degrees Celsius and 200 degrees Celsius. Concrete exhibits a pronounced softening as a result of elevated temperature exposure. Pore structure coarsening at end of recovery pore structure coarsening at end of recovery period after hundreds and 200 degrees Celsius exposures results in significant strength decrease of cement paste and concrete. Rapid cooling after temperature elevations evokes equal and irreversible structural quality deterioration of concrete and cement paste. Self-curing of concrete and cement paste after short and long-term recovery. Self-curing of concrete and cement paste after short and long-term recovery at 20 degrees Celsius does not contribute to in 1999 examined in films of mixture proportions of high power concrete mixes having different types of cements and mineral admixtures including silica fumes, fly ash and GGBS on durability of concrete. Durability of concrete mix was assessed by chloride ion penetration test. Chloride ion penetration for high power concrete mixes was less as compared to concrete mixes without mineral admixtures. Degree of improvement in durability varies with type of mineral admixtures and their quantity. HPC mix with optimum amount of silica fumes 10% exhibited very high resistance to chloride ion penetration. High power concrete mix with an optimum amount of silica fume, that is 10%, exhibited very high resistance to chloride. In fly ash, based concrete, siliceous fly ash SFA, siliceous fly ash of IS 3812 or BIS 2003A, BIS 2003B or Class F fly ash of ASTM C18, ASTM C618 is used as supplementary cementitious material incorporated as a cement replacement. Cement replacement level CRL is in range of 10 to 30% by mass in low volume fly ash concrete, while it could be as high as 50% in high volume fly ash concrete. Advanced Concrete Technology Program at CANMET in 1985 developed HVFAC, that is high volume fly ash concrete. This class of concrete has very low water content. Water binder ratio is 0.4, less than that. That's possible due to use of super plasticizers, and more than 30% of OPC by weight is replaced. More than 30% of OPC by weight is replaced with fly ash. There are numerous publications on mixed designs methods for HVAC. Parameters, water binding by ratio by trial and error method. It was proposed the idea of HVAC mixed design by taking into account efficiency of fly ash. Proposed the new strength cementitious materials water relationship for designs of HVAC mix taking directly into account characteristics of OPC FA and fine aggregate to be used in production of actual mix. Figure 1. This is figure 1. Relation between FCMF and water cement at 28 days. And you can see this ratio is 0.2 to 0.5. It starts at gap of 0.2, 0.25, 0.3, 0.35, 0.4, 0.45, 0.5. This is water cement mix ratio. Cement is material ratio effect. Water cement is metal ratio. And here is FCs or FM, and that is from 0 to 3 at a gap of 0.5, 0 to 0.5, 1.5. Likewise, and you can see these curves, and here is FCFM, here is 4.7322E. Likewise, you can see that higher FCFM here and lower here it is higher water cementing material. This comes down, this FCFM. So what it says, it have that study what it said, so that these methods drive governing parameters by trial and error. Now, suppose the null idea of mixed design by taking into account efficiency of fly ash. So emissions, this is about this is proposed new strength cementitious material, new strength cementitious material water relationship for design of SUFSE mix taking directly into account characteristics of OPC, FA and fine aggregates to use strength. FC is target strength and FM is strength of standard mortar. So this is FC is concrete strength and FM is strength of standard mortar, which is a mixture of cement, fly ash and fine aggregate with water cement ratio 0.4. And water cementing material OPC plus ash. R is correction, R square is correction efficiency. Test concrete containment vessel. Pre-stressed concrete containment vessels of third and fourth unit of pressurized water reactor based Japanese Ohi nuclear power station were constructed using LVFAC mix having specified concrete strength 45.88 MPa. This was highest specified concrete strength ever used in nuclear power station construction projects in Japan. No thermal cracking occurred and quality control was successfully implemented to obtain structural concrete strength satisfying specified strength by specified age during actual construction of PCCVS. One important example of using HFE-FAC in construction of NPP structure is size well B NPP. During period of 1988 to 1993, about 620,000 meter cube of fly ash concrete was used in construction of this size LB NPP power station, legal power station plant, consuming early nearly 137,000 tons of ordinary Portland cement. This is 137,000 tons of ordinary Portland cement. OPC 100,000 tons of fly ash. You can see 137,000 tons. Nearly this is ordinary Portland cement and 100,000 tons of fly ash. And 1,300 tons of sintered fly ash. Lightweight aggregate. Main power station buildings were constructed with a structural concrete mix having characteristic strength of 45 Newton per mm square. Main power station buildings were constructed with structural concrete mix having characteristic strength 45 Newton per mm square. Cement replacement level by fly ash was 40%. Says cement replacement level by fly ash was of cementitious component was placed as mass fill. Use of fly ash concrete will be reported to result in significant cost savings. Concrete produced with fly ash was extremely workable and well suited to pumping over long distance heights. Properties of concrete mixes such as durability, heat of hydration, creep and resistance to alkali silica reaction were benefited by incorporation of fly ash. Lightweight fly ash aggregate helped in avoiding thermal cracking. Both HFSC and LVFSC mixes were used in construction of some of concrete structures of India NPP, RAP 5 and 6, TAP 3-4, KEGA 1-2, structural fly ash based concrete mixes with varying CRL 23.5% to 40% were used for construction of some safety related structures and also a few non-safety related structures. Concrete mixes for non-structural applications had 50% CRL. Presently, all concrete structures of these power projects are being constructed using HVFC, that's high volume fly ash concrete with 40% CRL. HVFC with 50% CRL are employed for non-structural applications like mud mat, screed concrete, etc. It is reported the study conducted in Korea developed LVFAC concrete with 10%, 20% and 30% CRL for construction of concrete structures having dense 20% CRL. Is optimum mix for containment building and structural components with dense reinforcement when 2% fluidizing agent and 300 gram per meter cube of superplasticizers respectively are added. Durability and time. Study found that LVFAC with 20% CRL is optimum mix for containment, building and structural components with dense reinforcement when 2% fluidizing agent and 300 gram per cubic meter of superplasticizer respectively are added. Durability and time dependent deformation characteristics of these LVFAC mixes are better than mix without fly ash. High strength, specified strength 420 kg per centimeter square LVFAC concrete mix was used in construction of PCCBP of Japan and PP Gankai. Strength gain of concrete cast in some summertime was predominant in initial stage, then became insignificant till 1 year of age. Gain was noticeable from 1 year age to 5 years. On the other hand, The strength gain of concrete cast in winter's time is significant up to age of 1 year and remained almost constant till 4 to 5 years age. However, strength after 5 years was almost same. Study prospects of using ultra high strength concrete. Specified strength 39.2 to 98 MPa. Material as one of two features in developing optimal structural concept for nuclear reactor buildings for longevity of nuclear facilities, ease of decommissioning of nuclear power plant. Materials and structural tests using ultra high strength cement eastern materials. Materials and structural tests using ultra high strength materials and subsequent analysis of those tests for reinforced concrete shear walls were conducted. Positive results of this study showed a bright future for use of ultra high strength materials for reinforced concrete shear walls of self-compacting characteristics of SAC is achieved by appropriate employment of superplasticizer, low water to powder cement and mineral admixture, and whatever ingredients having particle size not more than 125 micron ratio, and use of VMA. Design of SCC mix is more complex than traditionally placed concrete mixes. All these methods put emphasis on rheology. Strength is taken care of indirectly by trials. New design methodology for self-comporting concrete mixes were designed with high volume fly ash method proportions in SCC mixture and specified target strength directly with minimum trials 20 to 40 grade So, SSC with high volume fly ash has also been. Let me see down, please. Yeah. Rheology and specified target strength directly with minimum trial M25 to M40 grade. SCC with high volume fly ash having CRL 40% and 50% for use in construction of civil concrete structures. The structural component of larger dimension can be constructed in shorter time with SCC. Photograph, figure 10 high column of turbine. Stand meter high column of turbine building constructed with SCC. Construction. Construction along with beneficial effect. Use of admixtures posed a number of challenges. Along with beneficial effect, use of admixtures posed number of challenges in areas of construction, which led to further development in construction techniques. Nuclear power plant concrete structures are complicated. Critical structures have thick common continuum elements, have thick continuum elements of complicated shape and embedded parts, penetrations. Construction activities constitute physical process of development. Physical process of developing HPC composites with silica fumes and fly ash. Characterization of ingredients, mixing method to manufacture fresh concrete, transportation, placement and compaction has significant effects on performance of NPP. Construction activities constitute physical processes of developing HPC composites with SF and FA, characterization of ingredients, mixing methods to manufacture fresh concrete, mix, transporting, placing, placement and compacting has significant effects on performance of NPP. Concrete structures, working out appropriate procedures for these components of physical process and curing alone with mixing method. Sequence of mixing and time of agitation. Sequence of mixing and time of agitation play a crucial role in governing properties of concrete mix, especially in case of high performance concrete. Mixing method of HPC should ideally be such that cementitious materials, particularly mineral admixture, is adequately mixed. Cementitious material, particularly mineral admixture, is adequately mixed. It was observed that effect of mixing method has significant impact on workability, strength and durability of high power concrete composites with SF, FA, GGBS, HRM. According to this standard method for HPC is to obtain first a homogeneous mixture of coarse and fine aggregates in mixer and then add cementitious material by, it says, a standard method for mixing is to obtain first a homogeneous mixture of coarse and fine aggregate in mixer and then add cementitious materials followed by water and super plasticizer. Agitation time does not affect, so that any further increase in agitation time does not affect homogeneity or workability of concrete. This is also necessary for economizing construction time. Efficiency of mixing method depends on when and how chemical admixture has to be introduced. So it says be optimized so that any further increase in agitation time does not affect homogeneity or workability of concrete. Also necessary for economizing construction time. Efficiency of mixing method depends on when and how chemical admixture has to be introduced into mix. Multi-stage mixing method has been found suitable for manufacturing concrete mixes with admixtures. Transportation and placement. Detailed specifications required to be worked out for transportation, placement and compaction of concrete with mineral admixtures. A purported development of specifications that were used in construction of containment structures of Indian nuclear power plant using concrete with silica fumes in hot weather. Two important aspects in this respect are maintaining adequate workability and use of cool concrete with silica fume for reducing heat of hydration in thick members. Use of retarder in concrete mix was very effective in maintaining workability for a longer duration. Addition of secondary dose of superplasticizer near pumping point was found useful. Pre-cooling of aggregates in addition to replacement of water with ice flakes is suitable in controlling temperature of fresh concrete. Also insulation of transit mixers. And concrete pipelines helps in controlling rise in temperature during transit. Pre-cooled concretes not only reduce thermal stress in mass concrete due to heat of hydration, but also curing. Curing of concrete is defined as maintenance of a satisfactory moisture content and temperature on concrete during its early stages so that desired properties may develop. Curing has more influence on development of properties in hardened state of high power concrete as compared to that of normal concrete. Because of less water content in former one, two-stage curing was adopted in construction of Indian NPP, initial and final curing. Objective of initial curing is to prevent moisture loss at early stage, and it should be carried out without applying water directly on surface of fresh HPC. Curing compound is not efficient for initial curing. Spreading of opaque color plastic sheets over fresh HPC contacting exposed surface is observed to be an efficient approach. Wet burlap may be spread over plastic sheet for reducing temperature of concrete surface. If FA and GGBS are not used, wet burlap may be spread over plastic sheet for reducing temperature of concrete surface if FA and GGBS are not used. Initial curing should be continued about an hour more than initial setting time of concrete. Final curing is wet. Final curing is wet curing by ponding water or spreading overlap, burlap under. Initial curing should be continued about an hour more than initial setting time of concrete. Final curing is wet curing by ponding water or spreading water, burlap or spraying water on exposed surface. 10 days of wet curing is sufficient for concrete with SF silica fumes. Concrete members of large depth, for example ring beam of primary containment, dome, are cast in number of pores, segmenting along depth. Concrete members of large depth, for example ring of primary containment, dome, are cast in number of pores, segmenting long depth, thickness of member. Exposed surface of segment, exposed surface of segmented pore with extended reinforcement forms construction joints for subsequent pores. Curing of this type of surface is an involved one and constructed with high strength concrete. Curing of this type of surface is an involved one when concrete constructed with high strength concrete, especially for structures with leak tightness as functional requirement. Exposed surface cannot be covered for initial curing, and latents need to be removed in order to achieve construction joints. This also provides, we can say, concrete members of large surface, as I said. Curing of this type of surface is involved in one when constructed by high strength concrete, especially for structures with leak tightness as final requirement. Exposed surface cannot be covered for initial curing, and latents need be removed in order to achieve construction joints of good quality. Exposed surface cannot be covered for initial curing, and latents needs to be removed in order to achieve construction joints of good quality. Providing a cover of opaque color PVC sheet after spraying of surface retarder and subsequent green cutting after final setting of concrete have been found to be an efficient approach for initial curing. Providing a cover of opaque color PVC sheet after spraying of surface retarder and subsequent green cutting after final setting of concrete have been found to be efficient approach for initial curing. This also provides appropriate in order to ensure uniform spraying by visual inspection. Says surface retarder may be mixed with the dye in order to ensure uniform spraying by visual inspection in hot and dry ambient conditions. Fog spray may be used. Final curing should be done adopting similar approach of wet curing of other surface. Design and verification of concrete structures. Designs and verification of concrete structures. Concrete structures of Generation 1 NPP were designed using working stress method. Concrete structures of Generation 1 nuclear power plant were designed using working stress method both for loads cases of normal operation and design basis accident conditions. Evolution of design approach witnessed from working stress method to ultimate strength method and then to limit state method in design of Generation 2 NPP. Load conditions for design remained same for this generation of NPP. That's normal and DBA conditions. Though the work on determination of ultimate load bearing capacity of containment structures for beyond design basis accident and seismic capacity against beyond design basis earthquake was initiated during this period. For Generation 3 NPP, all countries except USA adopted limit state method for design of concrete structures for load cases of normal as well as DBA conditions. Highlight of design of this generation NPP is safety assessment against certain BDBA severe accident conditions, particularly for containment pressure, seismic ground motion and commercial aircraft crash, practice of linear structural response analysis against loading of normal design as well as DBA conditions are prevailing from time of generations 1 to generation 3. Non-linear structural analysis is conducted for safety against BDBA or severe accident scenarios. A number of experimental works for confirmation of structural behavior in non-linear conditions were conducted during this. Major evolutions from generation 2 to generation 3. In comparison to generation 2 NPPs, design requirements associated to generation 3 present tremendous revolutions which should be accounted for by both regulators and operators. Regarding impact on concrete structures, most significant evolutions are: regular operational life has been extended by some designers to 60 years. It means that the life extension process, actually operational life, could be as long as 80 years or more. It should be pointed out here that although this might be regarded as long or very long by some individuals, such period of time are not exceptional in field of civil engineering. It should be pointed out here that although they might be regarded as long, very long by some individuals, such periods of time are not exceptional in field of civil engineering. Life expectations of dams and large bridges are even longer. There are numerous examples around the world of dams that have been continuously operated for centuries for various purposes, including occurrence is considered as a design condition of containment instead of being categorized as beyond design occurrence. A significant consequence is higher design pressure for containment. Taking examples of two PWR and EPR, containment design pressure of 0.65 MPa and A is 92 and is 0.6 MPa to be compared to design pressure of Generation 2 standards, which are respectively of 0.53 MPa for fringe and for standard, it is 1400 W. And 0.5 MPa for the VR 1000. A comprehensive and deep review of advanced light water reactor design is presented by IEA. After September 11th, every even so what to do? A comprehensive and deep review of advanced light water reactor design is presented. After 11 September, event commercial aircraft crash is now considered as a load case. Basically, it means that compared to case of an accidental military aircraft crash, such as considered in Generation 2 design assumptions, momentum of missile has been increased by a factor larger than 10. Minutes, that's my requirement. Let me finish this. After Fukushima Daiichi accident, it is clear that beyond design, extreme natural events should also be considered. In wake of accident, robustness of installations has been assessed under beyond design basis of accident. Robustness of installations has been assessed under beyond design designation earthquakes, beyond design basis earthquakes. In view of increasing level of seismic input motion to be taken into account, a new interest is paid to seismic isolation techniques, for which France has been a pioneering country, IAEA 2013. A better attention should also be paid to tsunami loads. Indian NPP Kalpakkam had been flooded in December 2004 after Sumatra tsunami. In comparison, a feature of Fukushima Daiichi cases that significant dynamic effects were observed due to wave velocity, which should be considered in safety assessment. Additionally, especially in countries that comply with IAEA requirement of implementing periodic safety reviews, safety of existing nuclear facilities should also be assessed against these updated load cases, which is very challenging. Various approaches and methodologies have been developed and applied to cope with this difficulty. Hydrogen explosion risk has been mitigated in some countries by implementing hydrogen recombiners. Hydrogen explosive risk has been mitigated in some countries by implementing hydrogen recombiners. More realistic estimates of containment structures, capacities under high pressure have been made possible in both in terms of leak tightness and human limit. Okay, now 6:45. I'll go for 5 minutes and come back. And meanwhile, we can be clear about this. I'll be back, okay? And I'll be back in 5 minutes. You can take care of this by that time. I think it's appropriate to go at this moment. So we are back here, and it's now of course, I'll put off the switch better. I'll put off the switch. Now it says, there's methodologies that have been deployed to cope with this difficulty, and that is here we can say this is hydrogen explosion risk. Hydrogen explosion risk has been mitigated in some countries by implementing hydrogen recombiners. More realistic estimates of containment structures capacities under high pressure have been made possible both in terms of leak tightness and of ultimate limit state. More realistic criteria have been used for assessing aircraft crash effects, such as developed hereunder. Seismic margin assessment method. Seismic margin assessment method, such as developed by EPRI and endorsed by NRC and later by IAEA, is now considered as an international good practice for dealing with BDBE. Seismic probabilities safety assessment. Seismic PSA has also been used in several countries in order to assess seismic risk and how to optimize decision making process of safety upgrading actions to be implemented. In following, a focus is made on progress in assessment of containment pressure, capacity, and on those significant evolutions driven by extreme external hazards, namely commercial aircraft crash and extreme earthquake. In knowledge of authors' developments on design basis principles against tsunami are not yet stabilized, although IAEA structures. Although research on high association integrity of containment structures or vessels, although research on integrity of containment structures or vessels for nuclear power plant has been conducted around the world, it is recognized that most comprehensive experimental efforts has been conducted in Sandia National Laboratory, primarily under sponsorship of U.S. Nuclear Regulatory Commission, after accident in 1979 at Unity of 3, Mille Island. A series of increasingly large and complex tests of scale model of containment structures and components were conducted in Sandia National Laboratories between 1983 and 2001. Latest and most significant was constructed by Nuclear Power Engineering NUPC NRC model consisted of 1:4 scale model of pre-stressed concrete containment vessel of an actual nuclear power plant in Japan. OEO3 1126 MW pressurized water reactor unit. One of 4 units comprising Ohio nuclear power station located in Fukui Prefecture. Design pressure for model and prototype is 0.39 MPa. Features and scale of PCCV model were chosen so that response of model would mimic global behavior of prototype and local details, particularly those around penetrations, would be represented. Model includes a steel liner anchored to concrete wall, concrete shell. Steel liner anchored to concrete shell. Details of design and construction are reported in PCCV test report. Oral geometry and dimensions of PCCV model are shown in figure 3. Pre-stressing levels for model tendons were selected so that net anchor forces, considering all losses due to anchor seating, elastic deformation, creep, shrinkage, and relaxation, a type of limit state test methods matched those expected in prototype after 40 years of service. Construction started in 1997 and was completed in 2000. Concurrent with construction of model, Sandhya installed nearly 1,500 transducers to monitor strain, displacement forces, temperatures and pressures in model. Figure 3, this is model tested by Sandhya National Laboratory, and this is what we will discuss later. We'll take up this later because it takes time sometimes, and of course it's an interesting one, this file. It's an interesting one, and we think you have to take care of this. You can get my email ID if you wish. It's up to you. Suraj Engineer. Suraj_engineer@yahoo.uk. If you wish, and you can see my profile, and you can see again this file, that is quality approach, and also I want to consider this section, this elevation, and we will be back soon. This kind of title being, we have gone through certain concrete case studies. You may say, I'm agitated person as far as engineering is concerned, really. Not agitated by force, not agitated by physical approach, agitated by contemplation. Contemplation, agitation is important. It's not physical dynamism or visionary dynamism, it is contemporary action is required. We have to understand this point. I'm not saying I have to fight with someone. Agitation comes to my mind when I talk of requirements. Because requirements is requirement, and we cannot go against that. No, we can't go against that, and nobody is permitted to go against that. Why should go against that? It's very, very practical point. So my dear friends, I hope you should also start thinking of qualification, not qualification, qualification I'm saying, because you are also not spared. You also require to get quality done, not to compromise with quality. There is no requirement of quality compromising, because quality is quality, and there is no way that we can think against that. When read that works quality cannot be compromised just in name of fragile quality system. Quality system may fail, but works quality must perform, which it doesn't happen currently in entire scenario. Is where check is required, and this check is urgent. If we cannot do it, then we are not dedicated and concerned engineering community. I can say that. Our approach should be that. But are we? I'm sure we are not. I think we should be. Thank you very much.